Okay, week 14. Week 14, basically determinants, the uses of determinants, typically with area. That's the big concept, by the way. And also Cramer's rule, all right, to solve systems of linear equations. All right, so we covered determinants. We gave it, certainly it seems like a computation for a lot of students, but there is a visual to it. We did briefly talk about the visual being an area. All right. I know it's difficult. I know it's abstract. Determinants pop up a lot, though. The techniques we talked about in computing determinants are going to bode well for even larger systems, but we're not going to go beyond a 3x3 for you. All right. We talk about invertibility. That, if you remember back to the form of a square matrix, that was 1 divided by the determinant for that 2x2. Determinant can't be 0. So if the determinant of the square matrix is 0, it indicates the matrix doesn't have an inverse. We talked about inverses. All right. There's great visualization on the web if you want to take a look at that. We talked about Cramer's rule. We talked about the derivation of Cramer's rule, and that it was a nice formula for solving systems of linear equations. All right. It really was a nice formula. I'm not a big fan of that. I always go back to like that augmented matrix, though, and I think that's probably the easiest way of doing a system of linear equations. Of course, inverse is another possibility, and Cramer's rule is certainly another possibility. Many teachers at Essex, though, believe that Cramer's rule is the gold standard for you guys when you get to upper level courses. All right, so be aware of that they expect you to know Cramer's rule. All right, so we went through examples. The examples we went through are pretty straightforward. They had to do with determinants. All right, and we went through all those examples. My hope is this, that you've paid attention and you understand what was presented to you and you're willing to move forward to do the problems. All right, so let's take a look. And what we're going to do now is we're going to switch screens and we're going to try to do the problems. All right, so let me switch screens and give me a second here. Okay, so what are we going to do? We're going to do problem number 1. It says compute the determinant of this. All right, so let's write this down. And I want the determinant of this matrix. And I want the determinant of this matrix over here, determinant of this. Let's write it down. We're going to do it by minor expansions. It's going to be 3 times some submatrix. The submatrix over here is going to be the matrix 4, 1, 6, 5 minus 1 times the determinant of some submatrix. That submatrix is going to be 2, 3, 1, 5. We'll do that later. Plus minus 2 times the determinant of another submatrix, and that submatrix is going to be 2, 4, 3, 6. Right, let me look at that. 4, 1, 6, 5, and make sure I'm copying this right. 2, 1, 3, 5. Yeah, and then 2, 4, 3, 6. Well, the terms are pretty easy to do. First, guys, 4 times 5 is 20. And then 6 times 1 is minus 6. Put that down. Next one, 2 times 5 is 10. 3 times 1 is 3. 2 times 6 is 12. And 3 times 4, 12. What do you get over here? Let's write the arithmetic down. And I'll certainly see if I can do it. It's 3 times 20 minus 6 is 14. We'll do that later. Minus 7, right? And the last guy's going to be 0. Put this over here. Let's keep going. 3 times 14, let's see. That's going to be 30 and 12, 42. Minus 7 plus 0. I'm not going to write that down. That's 35. Determinant's 35. All right. Let's do the next one. Again, fairly simple. It says the determinant of this matrix must be equal to 1. Well, let's write this down. The determinant is going to be, it's a 2 by 2. It's pretty simple to do. And that's going to be, let's see, 2x squared. Give me 1 second. Get me out of here. 1 second. It's going to be, oops, sorry about that. 2x squared minus a minus x, and that's going to equal to 1. It's going to be 2x squared plus x minus 1 equals 0. Let's keep moving. 2x squared would be 2x and x if it's factorable, right? And if it's factorable, 1 and 1. I'm about to go to the quadratic formula, who knows? And let's see, it looks like plus minus. Let's just check it. That would give me 2x squared. That looks pretty good. 2x minus x is plus x. That looks good. You did get minus 1. So what's the answers over here? X equals minus 1, or the other answer would be x is a half. Check your answers, and you're seeing it. All right, so minus 1 and 1/2. All right, let's go to the next question. And again, the next question, it says use determinants to find the area of the triangle with the given vertices. Well, let's write this down. Sometimes I want to say there's variations in how this is written down, but my goal over here is when something's written down and you find a variation of it, I'm not going to say you have to do exactly what I'm doing. For example, one thing you could do is you could draw the picture of this and certainly compute area in other ways, but they want to use the determinant to do that. I'm going to write that down for you. So the first thing I'm going to write down is just that determinant, and I'm going to put this 111. And this has been presented to you in class, by the way. I hope you remember that we gave you formulas for area. And again, if you have to go back over the notes, that's fine. Now, I know in my notes I put the 111 at the bottom, but this is the interesting about determinants. You could put it at the bottom, middle, or the top. I'm going to put it at the top now. So I'm going to put the next thing down with the points. And the first point, minus 7 and minus 1, 0 and 3, and 4, 8. And I'll put the determinant down. So it's going to be 1 times some submatrix determinant minus 1 times some submatrix determinant plus 1 time some submatrix determinant. And I'm kind of looking at it, and I'm just going to put the determinant down without writing what the submatrices are. So the first submatrix would be, let's see, 0 times 8, which is 0, and let's see, minus 12. Right? I'm just doing the determinant now. Let's do the next submatrix. It's going to be, let's see, minus 56, and then minus a minus 4, which is plus 4. We'll do the arithmetic later. And then it's going to be minus 21, minus 0. To put this down, it's going to be minus 12. And this is going to be plus, let's see, minus 56 and 4, minus 52. So that's plus 52 now. And then you're going to get minus 21. All right, let's keep going. And what do you get there? Well, let's see, minus 12 minus 21 is minus 33 plus 52. A lot of people get discouraged by arithmetic, and I'm not saying arithmetic is unenjoyable, but it does get tedious. And for a lot of students, it gets so tedious they want to use a calculator to do that. You should be careful about that, though. You don't want to go to your calculator, every time you see a problem you can't do. All right, but anyway, this is 19. What's the area? Well, it's going to be certainly plus or minus 1/2 of that number. I know the area is positive. So what's the area going to be? 19 halves. Okay. So what are we going to recommend you do is certainly look at the answer key and make sure you can agree that it's 19 halves. Now, 19 halves what? It's going to be square units. I just don't know what the units are. All right, let's go to number 3. I'm sorry, number 4. I'm sorry. And let's take a look. And it says solve using Kramer's rule. And I'm going to point out it's really not bad to do Kramer's rule. But again, you may have to go back and rethink the derivation. And I'm going to write this over here. I'm going to put the determinants down for you. We'll compute them slowly. So let's see. This would be 1 minus 3, 3, and 2. Now I'm going to put the top down. Now in the column of x now goes to constants 4, 1. And then I'll put this over here, minus 3, 2. Let's compute it. First guy's determinant is going to be 8 minus a minus 3, which is plus 3. What goes on the bottom? 2 minus a minus 9, which is plus 9. What do you get over here? 11 over 11, which is 1. So I know x is 1. Let's do the next one, which is y. Well, 1 minus 3, 3, 2. Let's put the top down now. The coefficients for the x, we're doing problem number 4, by the way, is going to be 1, 3. And what goes in the y column is a constant now, 4, 1. Tedious, but it's doable. Let's do the bottom. It's still going to be 11. I just did that. I need to do that over and over again. That would be 1 minus 12, which is minus 11 elevenths, which is minus 1. So what's x? X is 1. We did state that. What's y? Y is minus 1. Let's do number 5. All right. And we're doing number 5 now. I get a little better at this and write down x for you. Put the determinant down for you. And it's going to be 2, 3, minus 3, minus 1. Put the top down. And that's why teachers at Essex like it so much. It's really, if you knew the formula, you could write solutions down. I mean, you could do the determinant, by the way. You could write them down quickly for any dimension system. So let's take a look, as long as the determinant's not 0, by the way. So let's take a look at that. So I'm going to put 6, 5, and 3 minus 1. Let's do that. The bottom would be what? Minus 2. And then it would be minus a minus 9, which is plus 9. Top is going to be minus 6, minus 15, which is minus 21, and 7. So x would be minus 3. Let's do y. And what's y? Let's take a look at it. I've already done the bottom. That's 7. I'm going to do the determinant of the top now for that. And that's going to be 2 minus 3 and 6, 5. 7. That would be 10 minus a minus 18, which is plus 18. That's going to be 28 over 7, which can be the number 4. So the y is 4, the x is minus 3. We're doing good there. All right, number 6 more difficult. No doubt about it. It's a bigger problem. And I want to just get rid of all the other stuff over there. And I want to get the determinant at the bottom for x, y, and z like really quickly. All right, so let's put this one down. So I need determinant. It's going to be at the bottom. 5, 2, 1, 4, minus 1, 4, minus 3, 0, and 7. Let's see if I copied it right. 5, 4, minus 3, 2, minus 1, 0, 1, 4, 7. Let's write the determinant down. Pretty easy to do. 5. Let's see what you get over there. By the way, in the notes I call this D. It's 5, and then you get minus 1 times 7 is minus 7, and 0, 0. I'm not going to write that down. Minus 4, and what do you get there? 14, and then minus 0. And then what do you get? Minus a minus 3. I'm sorry, plus minus 3 times 8 minus a minus 1 is plus 1. This is going to be minus 35. This is going to be minus 40 and 16, minus 56. And that would be, let's see, minus 27, right? Boy, this is going to be tough, isn't it? Let's see, minus 35. Let's do the big numbers first. Minus 30, minus 50, minus 20. It's minus 100. 5, 6, and 7. Let's see, it's going to be 18 to minus 118. Okay, tough number. All right, let's do dx down now. And that's going to be 8, 2, minus 6, 4, minus 1, 4, minus 3, 0, and 7. Let's write this down now. So what do you get? You get 8. That's minus 7. Oops, that doesn't look like a minus 7, does it? And then what you're going to get? You're going to get minus 4. Let's see, 14, right? That's not so bad. Whoops, I went too quick there, didn't I? Let's see, right, -4. So yeah, no, it's 14. I'm sorry. And then I'm sorry, a plus or -3. Let's see, it's going to be 8. And then +6. Why? -56. Minus, that's 40 and 56, right? Wow, these are big numbers. And then what do you get over here? I'm starting to think I made a mistake somewhere. 2856 -3 07 8. Oh, I see it now. I'm going to write this down now. I definitely see my error. You may wonder why I think I see an error. I'm not getting what I want. Let's see. 8 -6, which is going to be -3 times 2, which is going to be -6. Let's keep going. That's going to be 112 minus 118. All right, what's x going to be? I'll write it down for you. X will be dx over d, which is -118 over -118, which is 1. Feel good about that. Let's do dy now. Whoops, I need to get this thing over here now, right? So let's see, 5, 2, 1, 8, 2, -6, -3, 0, and 7. I'm expecting things to work out pretty nicely. So what's this going to be? 5 times something -8 times something plus -3 times something. This is dy. Let's take a look at it. That's going to be 14 minus 0. That's not so bad. And this one's going to be 14. I mean, if I have to really keep careful here. 2 times 7, yeah, 0. The other one crosses 14 again. And let's do that last one. That's going to be -12 minus 2. All right, let's take a look. Let's see, 50 and 20, 70, minus 80, minus 32. Well, it's going to be, let's see, 14 times 3. 14 times 3, right? That's 30, 52, right? All right, oh boy, a lot of arithmetic. 52 and 70. That's going to be 122. Did I do that right? 50, yeah, 122. I think I made a mistake somewhere. I'm going to take a look at it again. Do my arithmetic here correctly, right? That's why I don't like Kramer's rule. It's an arithmetic problem. And let's see, 5 times 14. That looks good. -8 times 14. That looks good. And -3 times -12 minus 2 minus 14. So 3 times 14. Oh, 42. Sorry. Found my error. There you go. That's why I don't like it. It's arithmetic. Let's see, 70 and 42, 112. Whoops, write that down. Minus 112, which is going to be 0. All right. So what's y going to be equal to? I'll write this down for you. Y is going to be dy over d, which is going to be 0 over, and what was d? D was, not that it matters anymore, but di turned out to be, did I write d down? Oh, d was -118, I'm sorry, which is 0. What's y? Y is equal to 0. Got that one. Let's put z down now. And getting a little better at this. dz. Let's see, 5, 2, 1. 4 minus 1. 4. And 8, 2 minus 6. Kind of tedious, it really is. Let's put this down. 5 times something minus 4 times something plus 8 times something. Let's take a look at it. So it's going to be 6 and minus 8. Let's see if I did that right. 6 minus 8. And then I get minus 12. All right, minus 12 minus 2. Then the 8 would be 8. And then it's plus 1 then. Oh boy, more arithmetic. 6 minus 8 is minus 2. That's going to be minus 10. This is going to be minus 4 times, 4 times 14 then, right? 56. And then 8 times 9 is 72. And let's see, 56 and 62. Let's see, that would be 50 and 60 is 110, and 6 and 20, 118. So what do you get? dz over d would be z. dz is 118, and d was minus 118. That would be minus 1. And we're getting that right over here. That's done. Not bad. All right. Again, I know it's tedious. And by being tedious, I want to point out that people make mistakes, and you want to look at the answer key to make sure you can agree with that. So I think we're done with that page. Let's go to the next one. And the next one is a determinant for a 2 by 2. Oops, let's put this, make sure you understand what that says. And show that the 2 by 2 determinant A times B, determinant, not so bad. We can do it. You know what? I'm going to leave this one as a computer exercise. Okay, as a computer exercise, and see if you can do that. All right, so I'm going to switch over now, and I want to just go to a different share with you. Just give me 1 second. And let me open my terminal. All right, scrolling through the notes. I'm looking at this one over here. And I'm going to, sort of like remind you that we've done something like this before. Let me just clear, okay? Reset. I want to define some matrices over here. Before that, I want to do some variables for you. And I'm going to write the variables down for you. All right, look at these over here. A sub 1, A sub 2. I'm just going to start you with this. A sub 3 and A sub 4. And that's going to be var. Let's write this down for you. A sub 1, A sub 2, A sub 3, A sub 4, all right, I'm going to say A is a matrix. All right, let's take a look at it. And I'm going to do A1, A2. No, it's tedious. You want to learn how to type, though. I'm never very good at it, but anyway. Just typing this stuff in is all I'm doing. I'm going to display A. Looks good. I got the matrix. All right, let's do determinant of that. Boy, that did it too, right? Let's do B. Let's define some variables. B sub 1, B sub 2, B sub 3, B sub 4 equals var, defining variables, B1, let's see, B2, B3, oops, don't want too many mistakes, B4, it's a subscript, by the way. Yeah, no mistakes there. Let's do a matrix B. And let's write that down for you. B1. Let's see, B2. Okay. B3. B4. Let's display B. And we get B1, B2, B3, B4. Certainly you can do A times B if you like. Writes it down for you. Kind of complicated to look at, isn't it? Let me pull it up. All right. So let me just do something for you. Determinant A star B, determinant A star determinant B. I'm not saying it's going to work, by the way. There's a problem with software. And some software is better than others, but all right, wrote it down. All right, let me try this. True. All right. All right, let's go for what I just did. I looked at this problem here and I said, it looks like a lot of work by hand. And I laughed at it, like, yeah, you're walking and you want to get somewhere and said, maybe I'll take the bus instead. It might be quicker. There's more joy to walking, but you want to be able to do things by hand. And certainly when you get tired, use a machine. What I did over here, I defined two matrices, A and B, as specified over here. And I just verified this over here. What did I just verify? Determinant of the product AB is the same thing as determinant of A times determinant of B. We use the computer to do that. All right, you may want to look at the rest of the code over here. This one over here, basically solving a question that we did in the notes. I want to tell you what question that was. I believe that was question number 2. Let's make sure of that. Let's go back over here. And lo and behold, it was question number 2. All right, that covers it. And we'll move on to the next thing next.